Okay, so this is your do now. First things you have to think about is we've been doing these equations, or starting with force net, or all the forces acting on an object may cause an object with a mass to accelerate. Okay, so this guy is kind of like falling down to the earth, but he's not falling at gravity of 9.8 meters per second. Not falling at that acceleration. He's falling at a different acceleration. Why? Because he has two forces acting on the object. So here's your box. You have a force drag pulling it up, or this man up, and force of gravity going down. Now he's going down. So this is longer. This is longer because it's proportional, sort of, Okay. So let's put the two forces and let's see if we can solve what the force of drag is. What's this? We don't know. But we know that these are related to some mass accelerating. So first we're just going to put force drag, that's going up, plus a negative force of gravity going down is causing my mass, which is that guy, to accelerate. Now, there's something weird here. I need to make sure gravity wins. So I got to make sure that I'm not using a double negative. Now, I was a little fumbling around here in one of the classes. So you got to be careful when you put this information in. What is force of gravity? It's mg. It points down. So as long as I don't double negative it here, I'll be okay. So I'm going to put force of drag plus minus mg. And I'm not going to put that as a negative. Let's see what happens. Now plug in, what's my mass? Mass of the guy is 75 kilograms. Gravity is usually negative 9.8 meters per second squared, but it's taken care of because I put that there. And then what's my A? My A, and this is 2 meters per second squared. Oh, and he's going down too. So I got to show that these are winning. So that's like, I could technically put the A here negative. So let's put this in. I'm going to put 75 kilograms times my negative 9.8 meters per second squared. That negative went right here. I wish I had a black pen. I don't know where it went to. That negative goes right there. It's not a double negative. Just be careful, okay? It's not. I wish I could explain it clearer, but somehow I'm fumbling around with it. Kilograms. And then I'm going to do the acceleration of 2 meters per second squared. Now I'm going to get my numbers. The downward force plus negative 75 times 9.8. 75 times 9.8. And I know there's a negative there, so it's negative 735 newtons. Kilogram meters per second squared. Now watch it. There's not a double negative here. Whew. And what's this? Oh, but that's down. That's going down. So down and down. So I do 75 times 2. Oh, it's 50. 150, but whatever. So negative 150 newtons. Remember, force going down, that arrow needs to be less. Loses. This wins. So you got to check the amount. Now, how do I solve for force D? Well, it's got to be less than the force of gravity because that arrow has to be less. So I'm going to add 535 newtons to both sides. Force downwards is 150. I'll put a negative there. So 735 minus 150. 585 newtons. Now, and that answer is positive going up. Now that would make sense. Let's just check. I have 585 newtons going up and 735 newtons going down. So this side wins. This side will show that you're going downwards. All right. To the next one. Now you have this kid in a bucket, pulling up a bucket. So here's your bucket. There's a force of tension on the rope pulling it up. and it's stronger than the force of gravity. So this wins. So when I do my force net equal to ma, my acceleration is going up, my force of tension is going up, my force of gravity is just, making it go slower. So let's put the force, and I don't know what my force of tension is, so I just write Ft. There's no equation given, so I gotta write that down. So then I go plus minus the force of gravity will equal to my mass accelerating. Well, what's the force of gravity? That you can substitute an equation in, because you know it. It's also known as mass times gravity. Just don't forget that that's not a double negative. Put in your information, force of tension plus, oh wait, I want to put the units in here. 2 kilograms times negative 9.8 meters per second squared. Because remember, that's where that negative is going, right in there. So it's not a double negative. I still want to subtract the force of tension minus gravity. And I want to add that. Be very clear that I'm subtracting that. My 2 kilograms times my gravity, negative 9.8 meters per second squared. Now, if you list your variables, you don't have to write the units. Mass is 2 kilograms. My acceleration going up, is 7 meters. Oh my goodness! Ah! Oops. Is 7 meters per second going up. Ah, goodness gracious. That A is up here. 7 meters per second squared. Oh, you can't even see it. Sorry, guys. Whoopsie daisy. Even I make mistakes. And then gravity is negative 9.8 meters per second squared. And you can leave that positive and then just put it in here, negative. Now I have force of tension plus, and multiply that together, you're going to get 19 kilograms meters per second squared is a Newton, and that's where the negative stays. So force of tension is going to be stronger than that number. It's going to cause 2 times 7, that's 14 newtons to go up. So how do I solve for the force of tension on that string that causes that thing to accelerate? Well, I add 19 newtons to both sides. And the force of tension, and this goes to 0, equals 19 times 14. Let's check to see if it makes sense. This is 33 newtons. This is 19 newtons, and you accelerate it up. So this was stronger. If this side wins, you moved upwards. All right. Hopefully that was clearer than I did in class.